Hi guys. What we've been doing thus far from 14.1 to 14.3 is we've been looking at work, right? Work and energy. Okay? And the energy primarily was kinetic energy of a particle, half mv squared. Okay, now in 14.5 and 14.6 in a sense, we're going to carry on with this idea. We're looking at the principle of work and energy from a different angle, looking at conservative forces, potential energy, things like that. But here we are going to take a little, I wouldn't call it a detour, but we're going to look at work from just a slightly different angle before going back to what we were doing originally. And what we're looking at is something called power and efficiency. Okay, so we know that work is given by that, and we know that it was in joules. And we know that work, we know that it was given by this equation, F dot R, right? So work was the integral of F dot R. Okay, I'm just trying to lay a bit of a background. Let's consider a box here, and you want to lift this box up and put it on a shelf. Okay? Alright, so the work that you do to lift that up will be, say, this force. You're applying a force there, and there's a height, delta y. So the work done that you do, or should actually be a U, is equal to F times delta Y. Okay? There's nothing new there. Okay? But say now there's two different people. Say now you and me. Say now you lift this box up that's got a certain mass. You lift this up in 1 second. Okay? Then I lift this box up. Say now I'm not doing well that day, and it takes me 5 seconds to lift up that box. We have done exactly the same work. Alright? So it takes me 5 seconds, it takes you 1 second. Both you and me have done exactly the same work, because work is defined by force times the displacement. Okay? However, you've done it much more quickly than me. Okay? So this is where something called power comes in. Power. Power is the rate. It's the rate at which you do work. Okay? So let's have a look at this little discussion over here. Power provides a useful basis for choosing the type of motor or machine which is required to do a certain amount of work. For example, 2 pumps may each be able to empty a reservoir if given enough time. However, the pump having the larger power will complete the job sooner. So basically, here you had the larger power because you were able to carry out that same amount of work in a much smaller time. So power is given by this du dt. It's the amount of work over time. Okay? And we know that du is equal to F dot dr. Okay? Delta work is equal to F dot dr. So power is equal to F dot dr over dt. Now what is this? Dr dt. That is velocity. So here we go. Here is the equation for power. It is the force times the velocity. Force times velocity. And we'll look at some examples. But the important thing to understand is that we're talking about a rate of work. How much work is done in a certain time. And the higher the power, the more quickly you can carry out a certain job that requires a certain amount of work. Okay, I hope you're getting that. Then the next thing, I think I'll stop here and see you in the next video.